Today's lesson, section 2.5b, we're still talking about transformations of functions. We're just going to briefly discuss even and odd functions here. So for this one, you have, now even and odd functions are not the same thing as what you're thinking about like before, where if you have even, the arrows go in the same direction, like end behavior. This is talking about something else. When a function is even, that means that if you plugged in a negative value in for your x's, you would get the same function as what you started with. So that's what this first thing's saying. So f is even if f of negative x equals f of x for all x in the domain of f. For odd ones, if f is odd, then f of x, or f of negative x, will equal negative f of x. So that's telling you that if you plug in a negative x, then it switches all the signs. Okay? So you have the opposite function, basically, of what you had previously for all domain, or x in the domain of f. Okay? So then what that does is if a function is even, then your function is symmetric with the y-axis. Okay? So with the y-axis, you can flip it over it and it will be the same picture. For an odd function, it is symmetric with the respect to the origin. So that means that if you flip over the y equals x line, then you'll get the same picture. Okay, so think of this as a line where you have a slope of 1 and your y-intercept is 0. Okay, so that's the type of line that you're talking about. So to determine if a function is even, odd, or neither, okay, now neither means that it's not the same function, nor is it the opposite function, okay, where all the signs are opposite. Okay, so function can be neither. So let's say, look at A. So for all of these, we're going to plug in f of negative x. And so then for x cubed plus x to the fifth, I get negative x cubed plus negative x to the fifth. Now here, remember, odd powers keep the negative because negative 1 cubed is negative 1. So then you get negative x cubed. And then the same thing for the negative x all to the fifth. It'll be negative x to the fifth. Okay? So since I have the opposite signs of the function that I had previously, that would say that we are odd. Okay? So since we're completely opposite. For letter B, if I was able to do the same thing, plug in negative x, so you get 1 plus negative x all to the 6th power. Okay, now remember, even powers cancel out a negative because you have an even number of them, so negative times negative makes a positive, negative times negative makes a positive, negative times a negative makes a positive. So since they're all positive, then you get just x to the 6th. So we have the same function as what we started with. So here, because of that, that means this is an even function, so it's symmetric with respect to the y-axis. Now this last one, here I have h to the x equals 2x to the fourth minus x cubed. I want to do the same thing. Okay, so then now you have 2, which is fine, negative inside power that's even to the fourth, cancels it out, so it just becomes x to the fourth. And then here you get negative x cubed. The cube does not cancel out the negative because it leaves one of the negatives, so then it's just negative x. But notice that we have two negatives, so it makes it positive. So now you have 2x to the fourth plus x cubed. Okay, now looking at these two functions, okay, now the 2x to the fourth are the same, but the x cubed is not the same. we started with a negative x cubed, and now we have a positive x cubed. So one of them stayed, one of them switched. So since they're not both one or the other, then that means we are neither. So this is a neither. Our function's not either even or odd. Okay? That's it. Have fun.